Okay, so we're working on this topic, predicting the formula of binary ionic compounds. Okay, so what we're doing is we're looking for compounds that will form between these ions. So we're going to match a cation to an anion and a cation to an anion. So the easiest way to do this is to pair them up using a table. So this table is like a tool to help us figure out what compounds are going to form. So what I like to do, and I think what Alex teaches you, is if you take the cation. So remember, cations are positive charged, anions are negative charged. So we just put cations on one side of our table. So I'm going to put iron here and gold here. And then we're going to put bromine and sulfur along the top of our table. So it doesn't really matter which side they go on as long as anions are together on one side and cations are together on one side. And then this table is going to be our tool to help us predict which compounds we're going to form between these ions. So like this one and this one are going to form a compound. Gold and bromine are going to form a compound. Gold and sulfur are going to form a compound. So that's how we're going to figure out which elements to pair up. So again, we need a cation and an anion, a cation and an anion. And this question, you will have 4 answers every time. So that's a way to check. One thing you need to check is, do I have 4 answers? Okay. So then what we're going to do is iron and bromine are going to pair up. So I'm going to write them together next to each other. That just helps me see what's going on. So I have iron 2+, that's a 2+, sorry. And then we've got bromine minus. And then to figure out what they're going to form, we take the charge down. So 2+ crosses over here. I'm going to put a 2 down here. This is just a 1, so I'm going to put, we don't need to write the 1, but I can write it. And so this compound is going to be FeBr2. So Alex is really picky. I need to put the subscript here. The other thing that you need to watch out for is the cation goes first. In an ionic compound, we always write the cation first. So the plus charges will go first. We do not write the charges in the formula. We just write the number of each element. So FeBr2 will be the answer, one of the answers. So again, we're looking for 4 answers. So let's try this one. So we have Fe2+, we have S2-, and then we just crisscross the charges. So because there's a 2+ here, I'm going to put it down here. I need 2 sulfurs to balance this 2 iron and 2 irons to balance this 2 sulfur. I'm just crossing the charges down. So then if I write this out, this one we're going to have to simplify. I can see that, but let's go ahead and write it out. So I have Fe2, S2, and ionic compounds, we always have to simplify. So the answer would be, we're going to divide a 2 out of both of these. So then we end up with FeS. And we don't have to write the 1. If the answer is, oh, we just need 1 iron, then we just need 1. So what's going on here is that we need 1 iron 2+ to balance the charge of a 1 sulfur 2-. So we have a 2+ charge and a 2- charge. We just need 1 of each of those to balance. So FeS will be my answer for the second answer. I guess the order doesn't matter. I'm just looking. I need to look for 4 answers. Okay, the next one on our chart, we need to match up gold 3+ and bromine minus. So this is like showing my work. Au 3+ and Br minus. And I need 3 Br minuses to balance 1 gold. So this is AuBr subscript 3. I just need 1 3+ charge to balance 3 Br- charges. If it helps you to write this out, sometimes that's also helpful. I can be like, oh, well, gold is a 3+ charge and bromine is a minus charge. Compounds always have to be neutral. So I need one of these, and I need 3 of these, so that we have a 0 charge. If we added those up, 0 charge. Okay, hopefully that didn't confuse you. If that's confusing, don't think about that. Sometimes it's helpful to see that visually, to see that those charges. Okay, the last one is we have AU 3 plus, and we have S 2 minus, and then we crisscross the charges. So 2 goes down below the gold, 3 goes down below the sulfur. So this last answer will be AU2 S subscript 3. So that's an answer, and that's an answer. So then I'm going to go ahead and type that into Alex, and we'll just make sure. So let's go ahead and check that in Alex. So we have FEBR, and there's a shortcut. I don't know the shortcut. BR2, and then FES, comma. We have AU, BR, subscript 3. And then the last one is we need AU, 2 of those for every 3 sulfurs. Okay, let's go ahead and check that. Oops. Okay, let's try another one. Okay, this one has some bigger charges, so let's try this. So I'm gonna write this down. We got zinc 2 plus, vanadium 5 plus, chlorine minus, oxygen 2 minus. All right, so our next problem, we're going to do the same thing. So we're going to find our cations, and then we're going to pair them along one side of our table. So zinc 2 plus, vanadium 5 plus, and that's going to go on one side of the table. And then on the other side of the table, we have our anions. So chlorine minus, O2 minus. So then we just pair up using this table. So we need a zinc 2 plus to go with chlorine minus. And then we crisscross the charges. So the 2 goes down, the 1 goes down. We have zinc chloride, ZnCl2. Okay, the next one is Zn2 plus, O2 minus. Then we crisscross the charges. So we need this to have a 2, this to have a 2. And then we're going to simplify. Divide by 2, divide by 2. Zinc oxide. Okay. And we don't write ones. So this is just saying I need 1 zinc oxide for 1 oxygen. 1 zinc for 1 oxygen. I need 1 zinc for 2 chlorines so that our charge is balanced. Our charge cancels to 0. Okay, here we go. So we've got vanadium 5 plus. Now we have chlorine minus. We're going to crisscross the charges. So we need 1 vanadium for 5 chlorines. So vanadium Cl5, VCl5. And then vanadium 5 plus, oxygen 2 minus. Crisscross the charges. So we're saying we need 2 vanadiums for 5 oxygens. And we have 1, 2, 3, 4 answers. The other thing that we want to check is, can we simplify any of these? Nope. We simplified this one already. We divided out the greatest common factor. So that's our answers. Okay, let's go ahead and check this one. Where is our Alex? So type in those. Zinc, Cl2. We need ZnO. We need vanadium Cl. Oops. Shouldn't put a space in there. Oh, there's not a space. Okay. 5 and V2. O5. Okay, and then we'll check that, make sure that we got it correct. Okay, and we can do one more. Let's do one more together. So I'm going to write this down. And if you can do these faster, if you can start seeing them, then you can do it faster. Sometimes it's just nice, especially on the test, to show your work, make sure that you are really careful because Alex is very picky. You want to make sure that you're doing it really carefully. So we have calcium 2+ and iron 2+. Cations go together, anions go together. So F- and S2-. So they're on the same side of the table. Cations are on the same side of the table because we can't make an ionic compound pairing these together. We need a plus charge and a minus charge to get a 0 charge overall. So we have calcium 2+ and we have fluorine minus. So we're going to crisscross the charges. So 2 goes down, 1 goes down. We need 1 calcium for 2 fluorines. Don't write the charge in the formula. Write the cation first. Okay, we're just going to drop down here. So this is saying we need to pair up iron 2+ and fluorine minus. Cation goes first. Anion goes second. We need to crisscross the charges. So we need 2 fluorines for 1 iron. We don't write the 1. We don't write the charges in the formula. So that's our next answer. This is already simplified. And then let's go over here. This is saying pair up iron 2+ and sulfur 2-. Crisscross the charges. So we need 2 irons for 2 sulfurs. Oh, but we can simplify this. They both have a 2. We can divide by a 2. So iron sulfide. Iron. This would be iron 2 sulfide because it's a transition metal that doesn't form the same charge every time. All right, so that's, and then the last one here we would have Ca2+ going with sulfur 2-, and we need 2 sulfurs for 2 calciums, and then we can divide a 2 out of both of those. So then we end up with CaS. This is simplified. We don't write the charges. We put the cation first, or usually it's a metal, not always, but almost always it's the metal. And then we'll go ahead and check those in Alex. So we have CaF2, CaS, FeF2, FeS. Okay, let's go ahead and check that. Okay,